So this is a quick little demo of some software that I've been working on. Lately I've been spending a lot of time thinking about moon exploration and lunar rovers, and so I was kind of inspired to make this application. It's just a start, it's not even close to done, but let me just show you what we can do. So we have a little rover here, and right now it's on some approximation of the moon. The ground has a little bit of a weird texture on it. There's no craters or anything, but up here we have a generate terrain box. We can put in any integer in there, and this is just a random seed into the terrain generator. So then we'll hit go. How to make that loading box a little bit smaller. And now we see that we have a terrain in front of us with lots of craters, some rocks. Some of them are kind of precariously placed down there. Might want to improve the algorithm. We have 3 cameras up here, and right now I've just switched over to free view. In free view, I have this free camera that I can move around. I can look at lots of different features. I can press a button to go right back to the rover if I want to. And this view right here is the camera view. This is the rover's camera. So see myself moving left and right here in the rover view, and so I'm seeing what the rover would be seeing. But lunar rover might have a depth sensing functionality, perhaps a time of flight camera or something like that. And from this depth data, we would be able to deduce height given attitude of the depth camera, as well as a few other factors. So I put in a depth camera, or well, a height map generated from a depth camera feature. Let's turn that on right here. Yeah, so this camera shows our height map laid over. What it did is it sent, I think, 64 by 64 samples, and wherever they hit the ground, they've colored the cells with a height map. Dark blue is lower, I think it's about 0.5 meters from baseline 000, which would be kind of the origin of the rover, right in between its 2 center wheels. And then bright green is about 0.5 meters in the positive vertical direction. And so we can turn the rover a little bit. I'm just pressing a key. I have a little bit of rover controls here. And let's say we want to do another depth map scan, and let's try to get that crater in there. Switch to the camera view. It's right in the center of our camera, so let's scan it. We can see it in our height map view. This right here is the view of the rover if it were only seeing its height map. So it's kind of like its height map view of the world. And we can even kind of interestingly use this to drive around. So let's say we're doing right here, but now we're going in blind, so let's do a scan. Oh, okay, there's some rocks there. Let's do another move around in a scan. Ooh, big rock there. Let's move back to our visual cameras and take a look at it. Oh, yeah, it looks pretty good. Go back to our free view. Free view in an actual rover setting is something we would probably not have, although we could kind of construct something a little bit like it. Maybe we could have a free camera, but the ground recreation would obviously not be this high fidelity if we were far away from the rover. We might be able to get a high fidelity recreation near the rover with photogrammetry or something like that. So you see I'm moving around and just kind of taking a panorama with my TOF camera, and that gives me a pretty cool height map. Let's go back to this height map camera. I think it looks pretty great. And if we get bored with this map, we can first remove our height map that we generated, and then let's make new terrain with a new random seed. So we'll watch it load, la-di-da-di-da, filling in those nice little craters. And there we have a completely new, different terrain. And you can even program sequences in here. I just put a really simple panorama sequence. So it just goes around, and I think I have this panorama set for 6 evenly spaced height map wedges that it's taking here. And you could use these to navigate or something. Probably be a pretty useful sequence. So I think that the next step that I'd like to do with this is, now that I have this height map, I can start assessing the safety of these cells. You can put a cost function. Well, first you discretize the map a little bit, and you make cells, maybe say like 10 centimeters by 10 centimeters or something like that. And each of these cells, you assign them a cost depending on how dangerous it looks to the rover, like what sort of incline it's at, likelihood of slip. There's a number of different things that could be dangerous to the rover from a mobility systems perspective. And then you use those costs in some sort of iterative pathfinding algorithm that's going to use heuristics. D-star light are pretty common algorithms. Might, just for starters, try running A star and seeing if it can get to a goal while minimizing the cost of the traverse, and which would visibly reflect itself as avoiding large rocks, for example, or craters. And that would be a pretty good way to start off with a kind of autonomous navigation problem. Anyway, this is just kind of a fun little tool, and hopefully you think it's as cool as I do. I've been having a lot of fun making it. Okay, bye.